Hello everybody, welcome into another lesson. So today we are going to use properties of exponents only on number problems. The next lesson we'll do it on variables, but it's important to review properties of exponents before we get into this because the same properties we used on whole numbers can be applied when you have fractional exponents. So if you have two of the same base being multiplied together with different exponents, we remember it's the same base to the power of the two exponents added together. And then if you have a base with an exponent in parentheses raised to another power, so power to a power, it's that base with the two to the power of the two powers multiplied together. Then you have your differences here. So if you have two of the same base, as long as that base is not equal to 0 in each of these three cases, because 0 in the denominator would give you something undefined. But if the power that the base is raised to in the numerator is greater than that of the denominators, then it's the same as that base to the power in the numerator minus the power in the denominator. On the other hand, if the power in the denominator is greater than that of the numerator, then it's 1 divided by that base to the power of the denominator minus the numerator. And then, of course, if the two powers are equal in the numerator and denominator, you just get 1, because that'd be like dividing it by itself. And then if you have a base to a negative exponent, remember that's just 1 divided by that base to the positive exponent. You would just literally take that base and make the exponent positive in the denominator. And again, that base can't equal 0 because you would end up getting a 0 in the denominator, which is undefined. And then, of course, if you have two or more bases in parentheses that have powers raised to a power, it's the same as taking both bases to their powers times the power outside the parentheses. It's literally just more than one power to a power at the same time. And then if you have one base to a power divided by another base to a power, and that quantity is raised to a power, it's the base in the numerator of the power it was raised to times the power that you're raising that whole thing to over the numerator to the power times the power on the outside the parentheses, provided the base doesn't equal 0. So all this we're going to keep in mind for the problems we're about to do here. So now that we have fractional exponents, we're going to apply these to what we know, to what on top of yesterday's lesson. So let's say you have a problem like 3 to the 5/3 times 3 to the 1/3. So you have 3 to the 5/3 times 3 to the 1/3. Well, what's that? You have two of the same base being multiplied together. So remember, when you have that, all you have to do is raise it to the power of the two exponents added together. So 5/3 plus 1/3, well, that's 6/3, right? Well, what's 3 to the 6/3? That's going to simplify into 3 to the second. Well, 3 to the second is 9. You would end up getting 9 as your answer once you add your exponents. Simple enough. All right. This one, we have 5 to the 2/3. That quantity raised to the power of 1/2. So we have 5 to the 2/3 raised to the 1/2 power. So this is where you're going to take 5 raised to the power of these two exponents multiplied together. So what is 2/3 times 1/2? that would literally just be 1/3, right? You would get 5 to the 1/3, or in short, you would just get the cube root of 5. And if you care to get a decimal approximation, you can, but it's sufficient to leave it as the cube root of 5. That might be the best way to do it. Pretty simple. Now here's one. 4 to the 1/4 times 64 to the 1/4. Okay. So we have 4 to the 1/4 times 64 to the 1/4. Your first thought probably is, there's nothing we can do with this. They're different bases. Well, okay. Ask yourself this. Is 4 to any power, if you raise 4 to any power, do you get 64? You do. If you raise 4 to the 3rd power, that gives you 64. So here's how you want to rewrite this. You'll keep your 4 to the 1/4 times what you're going to have now, that's 64. Rewrite that as 4 to the 3rd, right? Because 4 to the 3rd is 64. That whole thing would be to the 1/4. So now you have 4 to the 1/4 times 4 to the 3rd, that quantity raised to the 1/4 power. Now you'll just multiply these two exponents. What you're going to have is 4 to the 1/4 times 4 to the 3/4. Now you have the same base. So the idea is, if you can, turn it into the same base. 4 to the 1/4 times 4 to the 3/4, well, that's going to equal 4 to the 4/4, or simply 4 to the 1st, which would just give you 4. So all that work, you just get 4 for your answer. They do try to trick you sometimes. Alright, now, you have 1 over 36 to the negative 1/2. So you have 1 divided by 36 to the negative 1/2. Okay, here's something. So, if you have a negative exponent in the numerator, you bring it down to the denominator and make it a positive exponent. Well, the opposite way is, if you have a negative exponent in the denominator, you bring it to the numerator and make it positive. So that would be 1 times 36 to the positive 1/2, or simply 36 to the positive 1/2, which is simply put the square root of 36, which we know the square root of 36 is 6. So in the end, you should just get 6 for your answer. All right. We have 7 to the 1/5 over 7 to the 3/5. All right, so you have 7 to the 1/5 over 7 to the 3/5. This is where it's about to get fun. So the power in the denominator is greater than that of the numerator. So what's this about to turn into? That means you're going to favor the denominator. Your numerator will become 1. You'll end up having 1 over 7 to the 3/5 minus 1/5. That'd be 1 over 7 to the 2/5. Okay. Here's something else, though. What is 1 over 7 to the 2/5? That is 1 over 7. That is 1 actually over the 5th root of 7 raised to the 2nd power, right? That's 1 over the 5th root of 7 raised to the 2nd power. As we know, an expression is not considered to be in standard form if you have a radical in the denominator, and in this case you certainly do. So what are we going to do to rationalize the denominator? Well, if it were to the 2/5, once you have to multiply everything by 7 to the 3/5, that's exactly what you're going to do. So you're going to multiply both the numerator and the denominator to rationalize this by the 5th root of 7 raised to the 3rd power, right? Because that'd be 7 to the 3/5. If you do that, you would just get 7 to the 1st in the denominator. But in the numerator, you'll still have that 5th root of 7 raised to the 3rd power. So you have the 5th root of 7 raised to the 3rd power in the numerator divided by 7 in the denominator. And that's the best we can do with this for standard form. So always remember, you have to rationalize your denominator. So you would get the 5th root of 7, that quantity raised to the 3rd power, divided by 7 for your final answer when you rationalize the denominator. And I do got more. Alright, let's see. We have 70 to the 1/3 divided by 14 to the 1/3. Alright, so 70 to the 1/3 divided by 14 to the 1/3. Well, it's important to know a property of exponents, that if you have both the numerator and denominator to the same power, that is no different than separating this by taking that numerator divided by the denominator, which would be to the 1st power, and then you can raise the whole thing to the 1/3 power, right? That's no different. This is going to help you immensely. Now, what is 70 divided by 14? That's 5. That would turn this into 5 to the 1/3, which would simply give you the cube root of 5. That's the best we can do for that. You end up getting the cube root of 5 as your final answer. It's important to understand these properties of exponents so you can simplify. All right, good one. So we have the quantity of 2 to the 1/4 times 2 to the 1/3, all that raised to the 6th power. So we have the quantity of 2 to the 1/4 times the quantity of 2 to the 1/3, that whole thing raised to the 6th power. Well, of course, order of operations dictates we deal with what's inside the parentheses first, right? So inside the parentheses, you're multiplying two of the same base to different powers. What does that mean? You got to raise that base to the sum of the two powers. So let's work out what 1/4 plus 1/3 is. Well, that would end up giving you 3 plus 4 over 12, which would end up giving you the 7/12 power, okay? So this would end up turning into 2 to the 7/12 power raised to the 6th, which, you multiply these, you'll end up getting 2 to the 7/2 power. Well, we can simplify this further, right? 2 to the 7/2. We certainly can. Isn't this the same as 2 to the 6/2 times 2 to the 1/2, right? Because if you add 6/2 and 1/2 together, what do you get? You get 7/2. Well, what's 2 to the 6/2? That's 2 to the 3rd, right? You'll get 2 to the 3rd times 2 to the 1/2. Well, what's 2 to the 3rd? That's 8. Then what is 2 to the 1/2? That's a square root of 2. So you literally would end up getting 8 times the square root of 2 as your final answer. Once you simplify this, you'll end up getting 8 times the square root of 2. So always try, especially when you have a fractional exponent where the numerator is bigger than the denominator, try to simplify it as much as you possibly can. This gives you 8 times the square root of 2 in the end as your end result. All right. Good one. So we have 5 to the second divided by 8 to the second raised to the negative 1/2. So we have 5 to the second over 8 to the second raised to the negative 1/2. Okay. Well, this is going to be the same then as 5 to the second to the negative 1/2 power divided by 8 to the second to the negative 1/2 power. So now we just multiply the powers in the numerator and denominator. What do you get? 2 times negative 1/2 gives you negative 1, so you'd end up with 5 to the negative first over 8 to the negative first. Well, you notice then, in both the numerator and denominator, you have a negative 1 power, right? In order to simplify this, basically, since they're both negative 1s, they're just going to switch places and become positive powers, right? So that 8 would go to the numerator and become a positive first power. That 5 would go to the denominator and become a positive first power. So literally, you're just going to get 8/5. That would be the answer. You would literally just end up getting 8/5. All right, let's see here. So you have 6 to the 2/3 times 4 to the 2/3 all over 3 to the 2/3. Okay, so this one looks a bit messy, doesn't it? This is where it's about to really turn into some fun here. Let's look at 6 2/3 and 3 2/3. Let's split this up a bit here. So, what is 6, of course? 6 is 3 times 2, isn't it? So, I can take inside, I can make that 6 the quantity of 3 times 2 to the 2/3. And then what is 4? That's just 2 times 2, right? You would have all that times the quantity of 2 times 2 raised to the 2/3 power. And then the 3 to the 2/3, there really isn't much we can do with that, unfortunately. So there's where we're at now. Well, that 3 times 2 to the 2/3, that's literally going to be the same as 3 to the 2/3 times 2 to the 2/3, and then times another 2 to the 2/3 times 2 to the 2/3 all over 3 to the 2/3. This actually isn't as bad as you think now, since we've separated everything. Between the numerator and denominator, the 3 to the 2/3 cancel out. You're rid of that. So all you have now is the numerator with 3 expressions of 2 to the 2/3 power. So that means you're going to add all these exponents. In the end, you should get 2 to the 6/3. Well, what is 6/3? That's 2, right? So you should end up getting 2 to the 2nd power, which would give you 4. This is why understanding properties of exponents and how to separate them is so important. Because even though you may not have the exact same base, you can break them down into products of the same base, which would end up giving you 4 for your answer. I think it's actually pretty neat that you can do that. Okay. We have 125 to the 2/9 times 125 to the 1/9 power, all that divided by 5 to the 1/4. So we have 125 to the 2/9 power times 125 to the 1/9 power over 5 to the 1/4. Again, it looks like different bases, doesn't it? Well, ask yourself if there's a way to make these the same base. Does 5 to any power equal 125? It certainly does, 5 to the third, right? If we take 5 to the third power, we get 125. So you can write this as 5 to the third to the 2/9 power times 5 to the third raised to the 1/9 power all over 5 to the 1/4. Now we've got the same bases, which this is going to turn into 5 to the 6/9 times 5 to the 3/9 all over 5 to the 1/4. Okay, so now you just add everything in your numerator exponent wise. You would get 5 to the 9/9, which is simply 5 over 1. Over 5 to the 1, which would just be 5. We'll write that first power over 5 to the 1/4. This just made our lives a lot simpler, didn't it? We now have 5 to the first divided by 5 to the 1/4. Well, this is going to be a subtracting powers problem because you notice the power in the numerator is greater than that of the denominator. So if you take 1 minus 1/4, what do you get? You would end up getting 5 to the 3/4. You could leave it as 5 to the 3/4, or your teacher may want it in the radical form. 5 to the 3/4 is no different than the 4th root of 5 raised to the 3rd power. That would be the exact same thing. The 4th root of 5 raised to the 3rd power, or 5 to the 3/4. That's what you would get in the end. Alright. We have 12 to the 10/8 divided by 12 to the negative 3/8. So we have 12 to the 10/8 divided by 12 to the negative 3/8. Alright. Well, this is going to be where you subtract the powers, and definitely the power in the numerator is greater than that of the denominator. So this would turn into 12 to the 10/8 minus negative 3/8, which would turn into 10 to the 10/8 plus 3/8. That would give you 12 to the 13/8. Well, we need to simplify this a little bit further. 12 to the 13/8, isn't that the same as 12 to the 8/8 times 12 to the 5/8? That would give you 12 to the 13/8. Well, 12 to the 8/8, that's simply 12 to the first. You would end up getting 12 times, now the 8th root of 12 raised to the 5th power. And you're about to see something here. Yes, it looks like I put that 5th power under the radical sign. You can actually do that. It doesn't matter if I take that 5th power and put it outside of the radical with the parentheses around it, or if I take that 5th power and put it inside the radical. They mean the same thing. So literally in the end, you would end up getting 12 times the 8th root of 12 to the 5th power. That's the simplified expression you would end up getting. All right. Let's see, we have 10 to the 3/4 times 4 to the 3/4 raised to the -4. And you're probably thinking, yikes, what are we into? Well, clearly we don't have the same base. Well, at least not yet. Are there any similar factors between 10 and 4? Well, there's 2, right? So here's what we're about to do. Let's make some brackets. Okay. Let's make some brackets here. Let's deal with the 10. 10 is what? That's going to be 2 times 5 raised to the 3/4 power times, what is 4? Well, that's going to also be, that would be 2 times 2 raised to the 3/4 power. All that would be to the -4th. Okay. Now let's use the properties of exponents here. You would end up literally getting 2 to the 3/4 times 5 to the 3/4 times yet another 2 to the 3/4 times yet another 2 to the 3/4, all that raised to the -4th power. Alright, so good news is we have 3 numbers that have the same base now. If you add 3 to the 4ths 3 times, you would end up getting 9/4. You would end up with 2 to the 9/4 times 5 to the 3/4, all that raised to the -4th power. Well, now we just got to multiply all the powers here. So 9/4 times -4, that's literally going to be the same as 2 to the -9th times 5 to the -3. So we're about to get a very small number, actually. Okay, well, both of these are negative exponents, right? So they're going to move to the denominator. You would get 1 over 2 to the 9th times 5 to the 3rd. So you're about to get a very small fraction. 1 second here. Let me calculate this. 2 to the 9th is 512. Take that times 125. You're going to get 1 over 64,000. When you simplify this, you get 1 over 64,000. So that would be your answer, 1 over 64,000. So, let's see here. I think we're going to split this into a couple lessons, even with the numbers. So this lesson was about properties of exponents with rational exponents. Next lesson we'll do properties of exponents with numbers and radical expressions. So I hope everybody has a great day. Take care.